Hello everybody. In this video, that's an extra video about Boolean algebra, and I'm gonna give some examples of Boolean algebra simplification, because I didn't want the Boolean algebra lecture to be too long, so I'm just splitting on this video that with some examples of simplifications. So let's go. So on page 66 of the textbook, you're gonna see that we have this example here. So the equation is complement of A, complement of B, complement of C, or A, complement of B, complement of C, or A, complement of B, and C. And this B is really weird. So, okay, so yeah, so looking at the equation, you can see that you have some parts that some members that they have components repeated. So you have A and complement of B here and here. You have complement of B and complement of C here and here. So that's a really good case of that you can use the idempotency theorem. So what that theorem says that if I have A or A, it's equal to A, and the opposite is the same. So I can repeat a member of the equation without changing its behavior. So that's what we're gonna do here. So it's A, complement of B, complement of C, or A, complement of B, complement of C, and I'm gonna repeat this member here so I can have one piece to work this part and one piece to work that part, and that doesn't change the overall meaning of this, the result of this equation. So now that I have it repeated, I can use distributivity to show to isolate some members. So on this side I can use complement of B and complement of C isolated, and inside here I'm gonna have A and complement of A and A, or I can isolate here, I can isolate A and complement of B, and I'm gonna have complement of C and C inside here. So when we have something and the complement of that thing, it's equal to 1, and when I have one ended with something, it's just that something. So in this case, I just gonna eliminate these components here, and I'm gonna have at the end complement of B, complement of C, or A and complement of B. And that's the simplified version of this equation here. This you can find on page 66. So I have other two equations that by the end of chapter 2 we have some exercises. So we have exercise 2.13, and letter A of this exercise, there's the equation. It's y it's equal to AC, or A complemented, B complemented, and C. So this one, I think we can use distributivity again to isolate C. So we're gonna have A or complement of A and complement of B, and inside the parentheses we can use distributivity again, but in another way, that we know that A or like B and C, it's equal to A or B and A or C. So that's another distributivity theorem that we have. So inside the parentheses, what we can do, we're gonna have A or complement of A and A or complemented of B. And this one here, it's A and complement of A, so it's 1 and anything, it's that thing. So at the end here we're gonna have C, A, or complement of B, and we can redistribute inside the parentheses, so the final form will be something like this: CA or C and complemented of B. So this is the reduced version of this one here. And actually, if you think about number of gates, maybe this version here use less gates, but it's kind of the same. But okay, so if you go to letter B, another example that I want to show you. So y it's equal to complement of A complement of B, or A complemented, B, C complemented, or A or C complemented, and the whole operation, our operation is complemented. So we have a tip here that we are gonna use De Morgan to solve this, and I think it's the first thing that I'm gonna use. So I'm just gonna repeat here: complement of A, complement of B, complement of A, B, complement of C, or, and in this case, the Morgan theorem says that if we have a OR operation complemented, it can turn into a AND operation, but with the complemented separates here in the component. So we're gonna have A complemented and C complemented, but we already have a complement here, so it's complemented over a complement, so that's actually cancel each other. So it's you're negating negation, so it's we remove that. So if we rewrite this, it's going to be this: complements B, complement C, and A and C. So you can see that A repeats in all of the members. And one thing that we can do, we can start with this one here. So we can isolate A, and it's gonna be B, C, or C. So we isolate A, and we have all the other members inside here because of the distributivity. But now from here you remember that we have this characteristic here that we can apply distributivity over OR, and we can apply this again. So we're gonna have complement of A, and in this case it's gonna be complement of B or complement of C and C. So this component here comes from this those two components. If I apply distributivity, I'm just jumping one step instead of doing this. I'm just gonna exclude the first. I'm just jumping one step here. But in this case, you can see that now I have complement of C, and this is equal to 1. And we know that anything or 1, it's actually equal to 1, because so in this case I can eliminate B as well, and this is complement of A. And my final version of this equation here is complement of A. So this is the minimized version of this equation. So yeah, that's I think that's it for today. We have some examples here, and thank you.